We're going to go ahead and get started on the Unit 6 review. First problem is dealing with solving an inequality. We want to know where is y1 less than or equal to y2. Again, y1 is my parabola and y2 is the line. So I want to compare the y values on the line, and I want to make sure that the y values on the line are greater than the y values on the parabola, or the y values on the parabola are less than the y values on the line. So the first thing you want to do, just like we did with solving algebraically, is you want to find those critical numbers. And when you're trying to solve an inequality graphically, those are going to be the x values of your point of intersection. So if you take a look at these two graphs, they're intersecting when x is equal to -5 and at x equals 4. So if you remember, we did the number line test when we were solving algebraically. So you can still set up a number line even though we're solving these graphically. Again, look at your inequality symbol. It's less than or equal to. So we are going to include the critical numbers in the solution set. So I'm going to put a closed circle on my number line. So now the intervals we need to check is we need to check where x is less than -5. And we want to look to see, are my y values on the parabola less than the y values on the line. So if you take a look right here, for example, at -8. -8 has a y value of -4. And you can see the y value on the parabola is going to be much less than that. So I know that the y value on my parabola is a lot less than -4. So I do know that I'm going to have solutions for this inequality less than -4. Now I need to look in the interval between -5 and 4. And you can see that the parabola graph is way above the line between -5 and 4. So that means that the y values, for example, if you look at x equals 0, the y value on the parabola is 4, the y value on the line is -3. So there's going to be no solutions between -5 and 4 because the y values on the parabola are greater than the line from -5 to 4. And then finally you want to look at the y values greater than 4. So you can see the y values greater than 4. You can see how the line is much higher than the parabola. So for example, if you look at 8, you see that you have a y value of -1, versus on the parabola we know that it's going to be a lot less than that. So we are going to have solutions greater than 4. So in interval notation, this is going to be solutions of -infinity to -5. And again, you're going to use a bracket because we're including -5 in the solution set, and bracket for to infinity. So now we can use the number line test for a lot of different applications. For example, we want to find the domain of a square root function, and we know to remain in the real number system that we have to have values that are greater than or equal to 0 in order to stay in the real number system. If you take the square root of a negative number, you get into the imaginary system. So we know when you're trying to find the domain of anything involving a square root function, you've got to take whatever's underneath your square root and make it greater than or equal to 0. So I'm going to take x squared minus x minus 12 greater than or equal to 0, because I want to know for what x values, if I plug them in here, will give me outputs that are greater than or equal to 0. So remember, when we solve polynomial inequalities, you're going to factor. Again, you want to make sure you have always have a 0 on one side first, and then you factor. And you want to find your critical numbers. The critical numbers come from taking each factor and setting them equal to 0. So my critical numbers are going to be 4 and -3. And again, I'm going to set up my number line very similar to what I did in the previous example. Look at your inequality sign. It's a greater than or equal to. So since -3 and 4 is where we're equal to 0, I am going to include them in my solution set. So I have to do my number line test. Again, remember, I want these numbers to be greater than 0. So numbers that are greater than 0 are positive. So I have to pick a number. Notice my number line is divided into 3 intervals. I have to pick a number in each interval, plug it in to my factored form to see which one will give me a positive output to be a solution set. So for example, if I plug in a -4, Well, negative 4 minus 4 is a negative number. Negative 4 plus 3 is a negative number. And I know when I take a negative number times a negative number, it's going to give me a positive output. You don't actually need to find what the exact number is when you plug negative 4 in. All we need to concern ourselves is it a positive or negative number? Now I repeat it, I want to pick a number between negative 3 and 4. Easiest number to use is 0. So when I plug 0 in, 0 minus 4 is a negative number. 0 plus 3 is a positive number. And a negative number times a positive number will give me a negative number. So all numbers between negative 3 and 4 would give me a negative output. Finally, pick a number greater than 4. I'll pick 5. 5 minus 4 is positive. 5 plus 3 is positive. So I know that numbers greater than 4 would also be positive. Remember, I'm looking for the positive intervals to be my solution. So then my intervals are going to be numbers less than negative 3, numbers greater than 4. So in interval notation, this would be negative infinity to negative 3. And again, I'm going to use a bracket because I'm including negative 3 in my solution set. And then bracket 4 to infinity. So again, anytime you're trying to solve a polynomial inequality, you want to set up the number line test. So here's another question asking about domain, and notice you have a square root function. So just like we did in 2a, what you need to do is you're going to take whatever's underneath that square root, and we need to make it greater than or equal to 0. Because we want to find the values for x that would give us a positive number underneath the square root. So since this is a rational expression, the way you find the critical numbers is you set the numerator equal to 0, so that's going to be 3. You set the denominator equal to 0, which is 4. Now I'm going to circle that critical number. Because remember, when you have a fraction, you can never have 0 in the denominator of a fraction. So when I go to set up my number line, there's 3, there's 4. Again, I am going to include 3 in my solution set because that's where this fraction is equal to 0. However, at 4, this is where the fraction would have a 0 in the denominator. So 4 is going to make it undefined. So it's just a boundary marker on the number line test. So anytime you're dealing with a rational function, whatever critical number comes from the denominator will always have an open circle because we're not going to include it in our final solution set. So just like we did in the previous example, you need to pick a number less than 3. I'm going to go ahead and use 0. Plug it in for x. 0 minus 3 gives me a negative number in the numerator. 4 minus 0 gives me a positive number in the denominator. So I know numbers less than 3 will give me negative numbers. Now when I pick a number between 3 and 4, I'm just going to have to use a decimal of 3.5. 3.5 minus 3 is a positive number. 4 minus 3.5 is a positive number. So I know numbers between 3 and 4 would be positive. Then finally pick a number greater than 4, so I'll pick 5. 5 minus 3 is a positive number on the top, but 4 minus 5 is going to give me a negative in the denominator. So numbers greater than 4 would be negative. Remember, since this is a greater than or equal to, I'm looking for the positive intervals to be my solution set. So my solution set is going to be very small. It's going to be bracket 3 and then 4, but I'm going to put a parenthesis after the 4 because I'm not including 4 in the solution set. So now I'm just solving for number 3. I'm just solving inequalities. Again, this is a quadratic inequality. The first step is you always want to make sure you have a 0 on one side of the equation, so I'm going to have to add 10 to both sides. So again, what you want to do is you want to factor. Again, there is a GCF I can pull out, so I'm going to pull out that 2. And I can factor x squared minus 6x plus 5 into x minus 5 times x minus 1. So my critical numbers, again, the 2 is just a constant. I said x minus 5 equal to 0, so that's going to give me a 5. X minus 1 is just going to give me, when I set that equal to 0, 1. Now this is just a less than. So I can't be equal to 0, so then when I set up my number line test, I'm going to put open circles above the 1 and the 5. So again, because this is less than 0, I'm looking for the intervals that'll give me a negative solution. So if I pick a number less than 1, that's 0. 0 minus 5 is a negative number. 0 minus 1 is a negative number, and a negative times a negative is a positive. Pick a number between 1 and 5, so I'll use 2. 2 minus 5 is a negative number. 2 minus 1 is a positive number. So a negative times a positive will produce a negative answer. Pick a number greater than 5, which is 6. 6 minus 5 is positive. 6 minus 1 is positive, so that's going to give me positive. So then I know that my solution set is going to the only interval where I have negative numbers are between 1 and 5. So again, it's going to be, my solution set's going to be 1 to 5 with parentheses around it. So for x squared plus x minus 6 over x minus 4, again, we already have a 0 on one side. So what I need to do to find the critical numbers is set the numerator and denominator equal to 0. So what I'm going to have to do, however, is I'm going to have to factor that numerator to set it equal to 0. So I factor that into x plus 3 times x minus 2 over x minus 4, which is greater than or equal to 0. So my critical numbers, when I set the numerator equal to 0, are going to be negative 3 and 2. Now, since this is greater than or equal to 0, I know that I'm going to use a closed circle on the number line because that's where I'm equal to 0, so I will include those values in my solution set. So now I have to set the denominator equal to 0, so that's going to give me a 4, and I'm going to circle it. Because when I go to set up my number line test, I've got negative 3, which I'm going to use a closed circle because my solutions can be equal to 0. I'm going to use 2 with a closed circle. However, 4, because that's the critical number coming from the denominator, that's where the fraction's undefined, so I'm going to use an open circle. Again, I'm looking at greater than or equal to 0, so I'm looking at positive numbers to be my solution. So I have to pick a number less than negative 3. So that's negative 4. And again, you want to plug it into the factored form. So if I plug in negative 4 plus 3 is a negative number. Negative 4 minus 2 is a negative number. Over negative 4 minus 4, which is a negative number. So the numerator is positive divided by a negative, so I know that interval is negative. Plug in a number between negative 3 and 2, I'll plug in 0. 0 plus 3 is positive. 0 minus 2 is negative. So a positive times a negative is a negative. Over 0 minus 4, which is a negative, and a negative divided by a negative is going to give me a positive. Plug in a number between 2 and 4, so I'll use 3. 3 plus 3 is positive. 3 minus 2 is positive, so the numerator will be positive. 3 minus 4 is negative, and a positive number divided by a negative number is a negative number. Plug in a number greater than 4, which is 5. 5 plus 3 is positive. 5 minus 2 is positive, so I know the numerator is positive. 5 minus 4 in the denominator is positive, so I know I'm positive for greater than 4. So notice my solutions where I have the positive intervals are between negative 3 and 2 and greater than 4. So again, I am including negative 3 and 2 in my solution set, so I'm going to put a bracket, negative 3 to 2. But now 4, remember, is not included in the solution set, so it's going to be 4 to infinity. So that's how you solve your polynomial inequalities.